simple question. You're trying to buy a $500 coat, and you have a 10% coupon, and then the state tax is 10%. That's usually it's a lot less than that, but just make it simple. Let's just say 10% tax. Okay. After both are applied, would you be paying the exactly $500 or something slightly bigger or something slightly less? What do you think?
Which one is applied first though?
Okay, let's usually the coupon's applied first. Okay, yeah.
10% of like whatever is left.
Yeah. So would you end up paying exactly $500, something slightly less than 500, or slightly bigger? Slightly less. Okay. All right. How many of you say same? 500, same. Okay. How many of you say slightly less? Okay. How many of you say slightly more? Okay, that's good. You guys are good. Okay. So the correct answer is it ends up being slightly less than 500. And it says 500 is not an easy number to compute. Let's start with something even simpler. So let's say it was $100. Now, if you apply 10% coupon, what's the price after 10% coupon minus 10%? $90. Okay. All right, and then 10% plus 10% tax. What's the new price? What's the 10% of $90? 9. So you add that. What do you end up paying? 99. Yeah. So if it's 500, you'll end up paying 495. Now you might wonder, what if it's the other way? What if you add 10% and then subtract 10%? Would this be different? Then subtract 10%. What do you think?
It'd be over.
Okay, let's see. You add 10%. What do you get? 110, right? Subtract 10%. What's the 10% of 110? 11. So you subtract 10. You subtract 11 from this. What do you get? 99. Same thing. Huh. Okay. So the order doesn't matter. Okay. And it's not additive. So the reason I'm trying to tell you this is because there are two important things that you have to understand about percentage increases. Okay. The first thing is that they don't add like regular numbers. You can't add negative 10 plus 10 and get 0. It doesn't work like that. So one of the common misunderstanding is that let's say the store has everything 50% sale, and then you got your hands on an extra honor coupon just for you for 50% more. And you're thrilled because, oh, 50 plus 50, 100% sale, so I can just walk in and just take whatever I want and leave. Well, guess what? The police will be after you if you do that, because if it was for 500, the first 50% sale will drop this down to 250, but the next 50% will only take the 250 and cut that in half, leaving you with $125. So it means that if you have minus 50% and then another minus 50%, this is not 100% reduction, but this ends up being 75% sale. Okay, it's a bit different. Okay, so in order for you to see how these things work, it's important that you understand how the math works. So let me try to explain you what's going on just with math formulas. The first thing that you have to know is how to convert percentages to rates. So if you have 10%, what does that mean? That's 10 per means divide, right? And then cent means 100, just like century means 100 years, right? So it's 10%, and that is equal to 0.1 in terms of a number. So 10% as a number is equal to 0.1. You just have to divide by 100. This is what we are going to call it as the rate. So if you're given a percentage, you have to know how to convert it to rate. And then let's see how this 10%, well, let's do 10% increase. So if you have original price P, and this went to plus 10% increase, right? Then what happens is that you take 10%, 0.1, which is 10% of P added to the original P. Does that make sense? Point 0.1, which is 10% of P added to the original P, which means it's P plus, did you know that of means multiply? When you solve word problems, if you see the word of, often it's multiplication. So what you do is 0.1 times P, and that ends up being 1 plus 0.1 P. Is that okay? That's how you increase by 10%. Now, seeing this, can you guess how you can decrease by 10%? It will be 1 minus 0.1 multiplied to P. Okay? So now what you see is that if you start with the original price P, minus 10% means 1 minus 0.1 multiplied to P, and then there's 10% increase applied to this, so it's 1 plus 0.1 multiplied to 1 minus 0.1 P. That's what you get in this scenario. On the other hand, here what you have is original P, and then P times 1 plus 0.1, and then this one would be P times 1 plus 0.1 times 1 minus 0.1. So these two differences are really the order of multiplication. One goes discount first, and then increase by 10%. The other goes increase by 10% first, you discount next. So they are exactly the same, right? We know that because multiplication is commutative, all right? So multiplication being commutative explains us why different orders of discounts and increases end up giving you the same thing. That's one thing. Second is because it's a multiplication, not addition, that's why the application of coupons is not additive. So this 250% off would mean you have the original P, subtract 50%, discount by 50%, and discount by another 50%. And if you compute this much, that's 0.5 times 0.5, so that's the same as P times 0.25, which is equivalent to P times 1 minus 0.75. All right? So you know that this is the 250% coupons applied means you actually get 75% off, not 100% off. Is that good? Yes.
Did you get that one?
No, it's you always have the one here because one is the original value, and then you're applying discount or increment by some percentage.
I was saying like the one
You just always put one. The formula is either, so out of this discussion, all I'm saying is the following. Increase by R, rate R, that's same as multiplication by 1 plus R. Decrease by R, that just means multiply 1 minus R. That's it. That's all I'm saying. Yeah. That's the math. And if you know that math, it immediately tells you why all of these things that we are talking about works that way. Okay, then this was just a preamble for the actual lesson for today, which is the interest rates. So compound interest rate is the topic for today. And let me start off with a very simple question. Example 1. So let's think about this. This 6% interest rate is APR, annual percentage rate, and it's slightly different from annual percentage yield that you would see in the bank. I'll try to explain what APY is a bit later, okay? But when it says compounded monthly, usually the banks do it by compounding quarterly. Every 3 months, they give you interest, okay? What it's doing is it's dividing this 6%, which is 0.06. You're dividing this 0.06 into 12 equal parts, right? So you divide 0.06 by 12, which is 0.005, right? So that's the amount that's going to be added every year. That's what's going every month. Okay, that's the rate that your money will increase every month. So what it's going to be is after 1 month, your $1,000 will increase by 1 plus 0.005, because we're just talking about that, right? 1 plus the rate. Okay, and that's going to be, well, some value. Let's not think about the actual value for now. So 2 months, what's going to happen? It'll be 1,000 times 1 plus 0.005 applied twice. This is multiplied twice. Every time you increase by some rate R, you're multiplying, right? So you multiply this twice. Okay. So after 1 year, what's going to happen? It'll be $1,000 multiplied by 1 plus 0.005, so 12th power. Okay, because you're increasing this 12 times every year, after 10 years, what's going to happen? 1,000 times 1 plus 0.005 to the power of 120. That's what's going to happen. All right? Let's do the calculation, see what it does. So I brought my calculator. There's some of these calculations, I can't do it in my head. So let's see. 1.005 to the power of 120. And then I multiply that by 1,000. And you get the value as 1819.40. I rounded up from the thousands because it's only the cents matter, right? I think banks usually round down because they don't want to lose money. Yeah. But anyways, that's how it's going to work. Yeah. All right. Now, there's something that you should notice here, that when it's the second month, you're not multiplying, you're not adding the 5% of the 0.5% of the original money, right? It's the 0.5% of the money in the account, which includes the interest. So in other words, in this system, interest earns more interest. Now, that might not seem like a big thing to you because, like, so this is $1,005. So, like, 0.5% of $1,000 versus 0.5% of $1,005. It may not seem much different to you, but when you do this for a longer time, this kind of graph has something called an exponential curve. It grows exponentially because, in general, it's as a function of time. It's some value to some time, right? So it grows exponentially. Whereas if you only had $5 added to your account every time, the growth of the money will be linear. It'll be a straight line. Okay, and exponential curves, they grow fast. Yeah. So your money will grow very fast after some time. That's the important part. Um, now, do you have any questions so far? How we got this? Okay. So now we're going to redo this by introducing a few variables. Let's see how we can actually come up with the variable. So here I'm going to name this as R. So when I was applying that formula, I called this as R, but rather I'm going to call this as R. And this monthly, bi-monthly, I'll say N is 12. Now, why is that? That's because 12 is the number of times the interest rate is applied per year. Okay, so let me give you some common cases. So if you have semi-annually, that means N is 2. If you do quarterly, yeah, that means N is 4. If you do monthly, that's what we did. That will be N equals to 12. Weekly, that would be N equals to 52 weeks per year, right? Is that right? 52 weeks? 52, right? And then daily will be N equals to 365. Okay? Something like this. So those are different values of N. And of course, the more often you apply the interest rate, it will be better. Okay. And then what I'm going to call this $1,000, I'm going to call this as principal, P. The original amount of money that you put in, that's called principal. And this value after 10 years, that's going to be called A. Just for future value, the future value will be A. And 10 years, 10 is going to be T. Okay, with all this in mind, let's see how this is computed. See, the future value A is computed by taking the principal, right? And then doing 1 plus, how did we get this number? We took the R and divided by what? N, right? The 12, N. And then where did we get the 120? It's 10 times 12. 12 because that is N. So it's N times T. Okay. So that will be our formula to compute the future value. Right. So although this thing that I just erased was useful for a while, it's now going to be this formula that we'll use again and again. Okay. Sorry. P times 1 plus R over N and T. Now there will be another formula that we will use. After seeing this, you could be a bit more greedy and insist on the bank that you need your interest rate applied hourly or something. That'll be like 365 times 24 hours, right? That will give you more money because the interest rate is applied more often. And you might even say, oh, maybe take that as like every second. Yeah. You can even go continuously. Right? That limit would be interest rate applied continuously. So what kind of formula would that give us? Now, although I can't really show you the derivation, I could do it, but it's going to be too complicated for us to get anything out of it. So let me instead just give you a story. So we'll start with just $1 rather than $1,000 because it's easier. So let's think about the principal as $1 and increasing that by 100%. And just to make the story more relatable, let's say you're a child laborer in some illegal sweatshop in third world country where you get yeah, you get $1 per day for making some designer shoes for some multinational company or something, right? Okay, so your daily wage is $1, right? Yeah. Okay, yeah. And then one day your boss comes in and he's quite happy because he got another deal which will give him more money. So he talks to you and your friends saying that, okay, everyone, I'll give you guys 100% raise. Yeah, very good, right? Yeah. So it'll be $2 per day. Okay. Wow, 100% raise. That's pretty good. All right. But then you kind of realize that your boss is not so smart and you have more math skills. So you knock on his door and do a proposal. You say, instead of giving me just 100% right away, can you just give me two 50% raises? Uh-huh. Well, you know what you're doing, but your boss has no clue. He doesn't know math. So he says, whatever. Yeah, do what you like. And just go and tell the HR. Now, what happened? If you have 50% raise for the first time, you're multiplying 1.5, right? But then you're doing it twice. So it's 1.5 times 1.5, which is 2.25. So you're getting $2.25 rather than $2. Yeah, more than your friends, right? Your friends are getting $2, you're getting 2.25. Yeah. Okay, but immediately seeing that your boss fell for it, you knock on his door and say, no, I changed my mind. I would like to get 10% raise for the next 10 days. And the boss still doesn't know the difference. So he'll just say, okay, whatever. And you go tell the HR, and after 10 days, your daily salary would be something like $2.59 per, yeah, $2.59. You get extra 59 cents more than your friends. Okay, all right. So that's the idea. All right. Now at this point, and I'm so sorry if I feel like I'm making fun of the sweatshops, those terrible companies. Yeah, you shouldn't buy from them. Yeah. Okay. But it's just that I'm trying to make a point in terms of math. The math part of this is that you start doing this in your head and you realize there's a question here. The question is, can you play this game more to find out you can extend the number of percentage increases with smaller values? Like if you have like if you play this game over and over again with bigger n values, so 1% increase for 100, okay, and do this, would the number increase without bound?
I mean, it's an increase, but like, it's gonna get way less every single time.
Yeah, the thing that increases is not going to be that high,
Yeah.
right? So if you do this, you end up getting an upper bound, which is so let's try to write this as a number, and I'll try to explain. So it's like this. You're dividing the 100%. One is the rate for 100%, right? You're dividing this into n equal parts, right? And you're applying 1 plus 1 over n increase, right? You're multiplying this to the principal 1, and you're doing this increase n number of times, right? Is that good? N number of times, okay? And then you're making n go to infinity. So the symbol for that is limit n going to infinity. If you do that, the number that you get is 2.7182818. Yeah. So there's an upper bound to it. Now, we talked about this number a few lectures ago. Do you recognize what this number is? What is this? This is called E. Yeah, the natural number, Euler number E. So, and then I'm just going to cut the hard math deduction and just give you straight away what happens if you do this for in the general case. So if you took this and you took n to be infinity, which means your interest rate is going to accumulate continuously. If you do that, the n goes away because you've sent to infinity, and something like this one will appear. So it's going to be p times e to the rt. That's what happens. The value of this limit is going to be p times e to the rt. And this one will be continuous compounding.
The top one, the formula for it. The top one was that formula.
The top formula will be compounded n times yearly. And I was talking about, so for example, semi-annually you compound twice, so n is 2. Right? Weekly would be 52 weeks, so n is 52. So you increase this into hourly, minutely, secondly, and you end up with this formula. So anytime you see a continuous increase or continuous decrease, you're going to see E appearing in the formula. So some of you who take some science courses, they might see atomic decay of some elements like carbon-14, stuff like that. And for those, you see this E appearing in that formula as well. Okay. Now let me try to show you some demonstration of this formula. So example 1, find the future value if an account gives 5% interest rate and A, compounded quarterly with initial money $2,000, okay, and then B, compounded continuously, same $2,000 initial, okay, and sorry, I should have added here, after future value after 10 years. Okay. So find the future value after 10 years if account gives 5% interest rate, and there are two kinds, two problems. Try to solve it if it's compounded quarterly, and try to solve it if it's compounded continuously. Let's see the difference, all right? Okay, solution. Compounded quarterly, which formula do you use? The top one, right, with n equals 2. Quarterly means you do it 4 times, so n is 4. Semi-annually would be 2, okay? N is 4, okay? All right, and then the future value would be principal. Principal is the initial amount, $2,000, multiplied by 1 plus, what's the rate? Rate of 5% is 0.05 divided by, n is 4 to the power of 4 times 10. Okay? You know, if you followed the very first problem before this one, then this formula is not that hard to remember. It's easy to memorize. You don't memorize, it should just make sense. Okay, but let's use the calculator to do this. $2,000 times 1 plus 0.05 divided by 4, and then power of 4 times 10 is 40, so I'm just going to put that in. So I just put everything as it is into the calculator. You know that power is this, caret, right? So if you do that, you get 3287.238. Yeah, let's round down. The bank will probably round down. Okay. So it's really 238, but I deleted the 8 and rounded down because that's what banks do. Okay, so that's your future value. Yeah. On the exam, I wouldn't care if you round it up or down, but usually you're asked to find the nearest cents because that's how much the bank will be paying. They don't care about the thousands. All right, so that's the future value. Now, the interesting part would be, how would you use the second formula? Oh, I forgot to say something interesting. I knew I forgot something. This thing here, you can read this as PERT, right? PERT. It used to be easy because this was a very popular brand name of a shampoo in the 80s. You can still find them in Walmart or some other places. If you look at the bottom shelf where they put some cheap items that's not usually advertised, yeah, it's usually green label. Yeah. So it's the name of a shampoo, PERT. Okay, so you can just simply remember this second formula as A equals to PERT. That's a nice thing to have because this one just makes sense, but this one, I didn't give you the derivation. And frankly, even if you looked at the derivation, it's not so easy to remember this. So it's easier to just remember this as a shampoo name, PERT. Okay, so how do you use the PERT? Well, 2000 is your principal. E is just E. E is a number, okay? And then R is 0.05, that's your rate, times 10, okay? So let's put that exact thing into the calculator. 2,000 times second E to the power of 0.5. And you get 3297.44. Okay, slightly more, okay? Yeah, just a little bit more. But hey, it's an extra $10, right? I would take extra $10. So that's what you get. Okay, is that good? All right. Now, example 2, which is better? Okay. So let's say you have 6.25% compounded annually versus 6% compounded monthly. Okay. So for the raw number, this is bigger, but you know, this is compounded more often. So at end of 1 year, maybe this is better. Who knows, right? So the only way to find this out is by trying to see what happens after 1 year. So here's the solution. If you go with this, what happens after 1 year? P times 1 plus R. What's the R value? 0.0625. What's the N value? Annually. What does that mean? Only once a year, right? So N is 1. And let's just do it for 1 year. Okay. So that's like P times 1.0625 0.25. Okay, that's what happens after 1 year. All right. Now let's look at the second case. P times 1 plus. How do you convert that into rate? 0.06 divided by monthly. That's 12. Okay, how many times do you apply this? 12th power. Okay, so let's do that with the calculator. If you do 1.005 to the power of 12, you get P times 1.0617. So effectively 617 or something. That's about it. So which one's better? The first one. This wins. So the answer is this. Okay. Now, have you ever passed by a bank and they have like, we are selling a CD, it's 4.25 APY? Yeah. I forgot what CD meant. Does anyone know? CD? No, I forgot. No, compact, that's, CD is some kind of a product that the bank sells. So if you buy, say, a 3-year CD, what it means is that you put money in there, but you don't take them out after 3 years, until after 3 years. If you have to take out the money early, you get some penalty, right? But if you put the money and not touch it for 3 years, and then you get the APY, right? And the APY that's posted there is different from APR. See, this 6% will be the APR, but 6.17% will be the APY. So there's a slight difference because usually the banks, they give out interest rates quarterly, right? So APR and APY are different. APY is slightly bigger, and that's why banks always put the APY in there rather than the APR, because it looks better. Okay, so next time you pass by the bank, just make sure you look for that word, that acronym, annual percentage yield, APY. Okay, let's try out these questions. Example 3, if you want $1,000 to become $10,000 in 10 years, what should be the interest rate assuming the money is being compounded semi-annually, and in other cases, if it's compounded continuously? Let's think about that. So you actually have two problems. So 3A, what's the solution? Well, this, you're using the first formula because it's compounded semi-annually, and you're given the P and A. A is the future value, P is the principal. What's not given is the interest rate. That's the question. You're trying to find the interest rate. So let's just plug in everything into the formula. The future value, I want $10,000. The present value is $1,000, the principal. And then you do 1 plus rate R is the unknown. What's N for 3A? What's N? Yes? 2, yes. And then 2, what's T? 10 years. I keep using 10. I should have changed this to something else. Okay. All right, so you're trying to solve this for R. How would you solve this? Well, you can first start by dividing by 1,000 both sides, right? So if you divide both sides by 1,000, 10,000 divided by 1,000 is 10, equals to 1 plus R over 2 to the 20th power. Okay. Now, you have to get rid of 20. How do you do that? You can do the 20th root, or you can also take the 1 over 20th power to it. Okay. So you can put the entire thing, both left and right, subjected to 1 over 20th power. And because these exponents multiply, when you multiply, they cancel out. Now let's try to see what's 10 to the 1 over 20th power. 10, 0.05. That's going to give you 1.122 equals to 1 plus r over 2. And now you subtract 1 both sides, you get 0.122 equals to r over 2. Multiply by 2, you get r equals to 0.244, which is 24.4%. That would be the interest rate. Wow, that's a whopping number. Yeah. So if you want your money to grow 10 times after 10 years, that's a lot. If you put $10,000 and then after 10 years you get 100,000. If you put in 100,000, you end up with $1 million after 10 years. Yes.
So like for the last step, what did you do?
I multiply both sides by r, both sides by 2. Twice of 12, 1 to 2 is 244. Okay, so that's how you do the first one. I don't have, let me write over here. What about B? Well, this time you get the $10,000 as the future value, $1,000 as the principal. Hurt, E is always E. R is the unknown. 10 is the years. Okay. So once you have this, now divide both sides by 1,000. You get 10 equals to e to the r times 10. Okay, how do you get rid of e? Yeah. Yeah, you take log base e to get rid of this. So you get log base e, which is also known as ln. Okay. So you take ln, that's in your calculator. ln of 10 equals to ln of e of 10r. R times n is 10r. And ln and e cancels because ln is the log base e and e cancels. And that means r would be, 10r would be this, so you divide ln of 10 by 10. That's your answer. Let's see what that gives us. So ln of 10 divided by 10. That gives you 0.23. That's it, yeah. So you need 23% interest rate. Okay. Yeah, usually these are hard to come by. If you invested in some stocks that gave a huge return like that one, yeah. Maybe you bought Tesla when it was going really high, or Amazon back in the days or something, then you might have that much success. Okay, so let's try this one. What should be the principal if you want $1 million in an account that gives 12% interest compounded quarterly after 20 years? Okay, so which formula do we use? Compounded quarterly. Which one? The first one, okay. What will be the value of n? Compounded quarterly? 4, right? Time? 20 years, right? Rate? R? Yeah, 12%, 0.12. Okay. And what is this? $1 million. What is that in the formula? A is the future value, right? A is future value. Okay. All right, so now we are going to solve this. put all of these numbers in there. You have 1 million in the bank. That'll be nice. P, unknown. R is 0.12 divided by 4. So 4 times 20. So I put everything in the formula according to the values I have. How do we solve for P? The rest is kind of straightforward, right? This is 80, just compute this much. Let's see what that is. It's 1 plus 0.12 divided by 4 to the power of 80. 4 times 20 is 80. And what I get is, oh yeah. What I get is 10.64089. That's what I get. You get $1 million here. Okay. So now what do? You say P is equal to 1 million, 10.64089. What's that going to be? Times 1 million. That gives you 93977.096. That one we should round up. So you need something close to $100,000. So if you put something close to $100,000 and you put in some account that gives you good interest rate, that's a very good one. You can never find anything that gives you consistently like that. Yeah, even 7% is like really good. Okay. Any questions? It's quite straightforward, right? You want to leave something for your grandson. You guys are in college. You don't even have kids, but let's say you want to leave something for your grandson. It's an experiment, right? Yeah. And then, so you look for a nice, nice investment opportunity. You see a very good one, 7%. It's really hard to get something like that, but let's say some kind of investment opportunity says, oh, they give out 7% on average, okay? And you just put $1,000 in it and forget about it. Okay, yeah. Like maybe after 100 years, your grandson kids might find it or something. Right? Yeah. Would it be 100 years? Maybe more. I don't know. That's my question. How long would it take for that $1,000 to become 1 million? All right. So let's try to solve this. You will still be using the first guy. So 1 million is your future value. Your original principal is just $1,000. The bank gives you 7% interest, and it's compounded quarterly, so it's 4 times. And it's really this T that's in question. We want to know what the T is, right? Okay, let's proceed. You divide by 1,000, so that's going to be 1,000. A million divided by 1,000 will be 1,000, okay? Now the problem here is actually this will be the hardest question among all the examples that we solved today, because it's a bit different than what we were doing so far. See, when I was teaching you guys equations, if I had something like 5 equals to 3 to the x, how do you solve this? You would apply log base 3 both sides, right? So that log base 3 and 3 will cancel, right? That's how you would get the x value. It's not so easy to do that when you try to solve this. One, because your calculator doesn't have log base arbitrary number, okay? And 2, this is a very annoying number to take with the base. So you don't do it this way. And as a rule, what we're going to do is anytime you need to use logs when solving for interest rate problems, you will always use ln. Okay, so no question asked. Like anytime you need to use some kind of logs, you feel like you need some logs, always go for ln. No other kind of logs, just use ln. So always use ln in your calculator. So we're going to apply ln both sides. And you might not see why this is going to help us, but it helps us because this 4t can jump over the log. Okay? And that gives you ln of 1,000 equals to 4t times ln of 1 plus 0.07, whatever that is. Okay? And therefore, t is going to be this thing divided by this. So it's going to be ln of 1,000 divided by 4 times ln of 1 plus 0.07 over 4. Okay. Now I'm curious to know this. Is it like 200 years, 300 years? I'm not so sure. Let's try it. Yeah, it could be like, maybe it's 700 years. I don't know. All right, so it's ln of 1,000 divided by 4 times ln of 1 plus 0.07 divided by 4. Oh, 99.5. Okay, that's good. Yeah. Not bad. So this is 99.54 years. Yeah. Okay, so that makes sense. Yeah. So when your grandkids grow up, you can give them this account, and then they're gonna enjoy $1 million for $1,000 that you invested when you're young. Huh? I don't know. Maybe just as an act of gesture. Yeah.
They gotta work for their home.
Okay. Okay. All right. Okay.
Is it possible to get possible to get this in real life at 7%?
No. So I mean, well, to get 7%, you have to invest in a bit of a risky account, which means like you might the account may not be protected. Some years you might lose money. Yeah. So what they're gonna promise is like about 7% average, according to the past performances. They can't promise anything in the future. Yeah.
Is it hard to find a secured account that will guarantee a stable 7%?
I would
Or
say
you're more than likely to find a secured account that has like 5% or something.
Maybe in some other countries, and not
So
in
America's
U.S.
just screwed?
because it's really dependent upon federal rate. So Fed rate right now is above 4%. So you can't find anything that's like that. Huh?
During COVID, it was like 8.
No, it never went that high. But anyways, it went. They lowered it recently. They'll probably lower it again in the coming weeks. Yeah, but it's tied to that. If the Fed rate is close to like 1%, like before long time ago, like before COVID, it was something like 1%. In those days, it was really hard to find a CD that gave you like 2% or something.